The importance of groundwater in geotechnics. When it comes to building on or beneath the Earth's surface, one invisible force can make or break an entire project: groundwater. It flows silently beneath our feet, but its effects are powerful, far-reaching, and sometimes devastating. Today, let's uncover why understanding groundwater is absolutely critical in the world of geotechnical engineering. What is groundwater? Groundwater is the water stored in the pores and cracks of soil and rock layers beneath the Earth's surface. It forms when rainwater or surface water seeps through the soil and accumulates in aquifers, natural underground reservoirs. In geotechnical engineering, groundwater is much more than just water. It's a dynamic player that influences soil strength, slope stability, foundation design, and even the longevity of underground structures like tunnels and basements. How groundwater affects soil behavior. One of the key concerns in geotechnics is how groundwater affects the strength and stability of soil. When soil becomes saturated with water, the pore pressure increases. This can reduce the soil's effective stress, which is the pressure that holds soil particles together. As effective stress drops, the soil can lose strength, leading to problems like settlement, sliding, or even complete failure. This is especially critical for cohesive soils like clay, where swelling and shrinkage due to water content changes are common. In sandy soils, high groundwater can reduce friction between grains, making them prone to liquefaction during seismic events. Why groundwater matters in site investigation. Before any construction begins, engineers conduct site investigations to determine the water table level, the depth below the surface where soil is fully saturated. This helps them select the right foundation type, shallow versus steep. Design effective drainage systems. Plan for dewatering if excavation goes below the water table. And predict long-term settlement due to changing groundwater levels. Ignoring groundwater in site investigation can lead to disastrous consequences like uneven settlement, basement flooding, or slope failures. Impact on excavation and construction. Groundwater can turn a simple excavation into a complex challenge. When building foundations or basements below the water table, dewatering becomes essential. This involves installing well points or deep wells to temporarily lower the water table, using sheet piles or diaphragm walls to keep water out, or implementing drainage blankets and pumps. Failure to manage groundwater during excavation can cause soil instability, machinery hazards, and delays, costing time and money. Groundwater and slope stability. In hilly or mountainous terrain, groundwater can destabilize slopes by increasing pore water pressure. This reduces friction between soil layers, potentially triggering landslides or slope failures. To combat this, geotechnical engineers use solutions like horizontal drains to release built-up water pressure, toe berms and retaining structures to provide extra support, and proper vegetation and surface drainage to reduce water infiltration. Understanding groundwater flow patterns is crucial for safe slope design. Tunnels, dams, and underground structures. When building tunnels, underground parking, or subway systems, groundwater poses a major threat through seepage and water pressure. For example, tunnels must have waterproof linings and grouting systems. Dams must have well-designed cutoff walls or cores to prevent seepage. And underground tanks or vaults must be checked for buoyancy risk due to high water tables. A miscalculation in groundwater pressure can lead to uplift, leakage, or structural damage. Climate and seasonal effects on groundwater. Groundwater isn't static. It fluctuates seasonally and is influenced by climate conditions. Heavy rainfall can raise the water table, while drought can lower it. Long-term water extraction for agriculture or cities can cause ground subsidence, a serious issue in many urban areas. Geotechnical engineers must factor in historical groundwater trends and plan for variability. This means designing flexible systems that can adapt to changes over time. The bottom line: why it matters. Groundwater may be out of sight, but it should never be out of mind. Whether you're constructing a skyscraper, a dam, or a tunnel, understanding the behavior of groundwater is crucial for safe, durable, and cost-effective design. Ignoring it can lead to structural failures, cost overruns, and environmental damage. But when properly understood and managed, groundwater becomes an element we can work with, not against. Thanks for watching. If you found this video helpful, give it a like and hit the subscribe button. Here on Blueprint to Reality, we break down complex engineering concepts with clarity. Drop a comment if you've encountered groundwater challenges in real-world projects, or if you want to explore more hidden forces beneath the surface. Until next time, build smart, stay grounded.